I would like to talk to you about a binomial distribution. What is a binomial distribution? A binomial distribution is a small probability experiment that has two outcomes and repeating many times, n times. For example, when you had a coin, when you toss it, you get head or tail. If you toss it again, you get head or tail again with the same probabilities. So if the probability of head is half and tail is also half, the probability of next toss will be also half everywhere. Okay? Another example of this binomial experiment is if you ask a question that has a true false answer or yes no answer. So if I ask you, for example, are you married, you'll say either yes or no. If I ask another person, after that he will also say yes or no, yes or no. So this will be asking two people. Of course, we can increase this more for three people or more. So this will be the first person to ask, second person to ask, third person. So if I ask many people, it will be more stages. Okay, so now if the probability that I can ask a person and answer yes, he's married, suppose for example this is 0.3. Suppose I'm asking students and 30% of them are married, and according to classical probability, if you ask one of them, the probability he will say yes, I'm married will be also 30%, as we said before in classical probability. So that's 0.3. So probability that he will say no, of course, will be 0.7. Next student will be same thing, 0.3, 0.7, we're assuming the percentage does not change. Okay, so let us see another example. In general, if you do anything and you might pass or fail, so suppose you did something and then you either pass or fail, and then you try again, you may also pass or fail. So in this case, I also have a binomial distribution, or a binomial experiment, in fact. Let us see how the distribution comes from here. This is a binomial experiment now. Let us see how the distribution comes from. In fact, the distribution comes from a discrete variable. We should have discrete variable, and the variable in this case is a number of heads in this example. How many heads you got here at the outcome? See here, the outcome could be here head or head tail or tail head or tail tail. So we are counting the number of heads because we are interested in getting heads in this example. So suppose this is the interest event, and this is what we consider success. This is what we consider success, answering yes. This is what we consider success, having passed the test, for example, or passed something you're trying to do. So we want to count how many successes we did, how many people answered yes in the case of being married or not married, how many heads I got. This is my variable x. So my variable x in this case will equal 2 here, 1 here, 1 here, 0 here. This is my variable x. Okay, this is my discrete variable. Okay, so this is what I will get the distribution for. So in this case, I ask about the probability that x equal to 2 or 1 or 0. And what is given in the question is a certain event that we consider success, the probability of this event, which is called P, and the probability that it does not happen, which is called Q, and a number of repetitions, how many times this binomial or this two outcomes repeat, which is called n. N is equal to in this case. Similarly here, P is equal to 0.3, which is the probability of success. We consider this to be our success, or the interesting event for us. The Q, if the interesting event did not happen, which is not married. And how many times we repeat this? So that's 1 time, second time, third time. So in this case, n equal to 3. And of course, at the end, we're asking how many people got married. So if we have yes, 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 for example, yes, yes, yes. So that would be 3 here. So it could be 3, could be 2, could be 1, could be 0. Same thing here. We have, suppose the probability of passing in general is P, the probability of failing is Q, and then we're repeating this n times, all right? And I at the end ask you how many times you passed that test. If you took this many times, for example, that will be our discrete variable x in this case. Okay, so that's binomial. Binomial has the main parameters is P, because you can get simply Q by this formula. Q is always 1 minus P. So all what you need here to be given is the P, which is the probability of the successful event or the interesting event, and the N. This is the main parameters of binomial, N and P. And then the question itself will ask about certain number of successes happened at the end, which is this number could be anything from 0 all the way to the largest number is n itself. So x will always be from 0 to n. Let us see some examples. In this example here, the first one, 60% of drivers use a seat belt. Select 5 drivers. What is the probability 3 of them use seat belt? Now we're searching for n, x, and p. So if you notice here, the percentage is actually equal to the probability. When you select one of them, he will be using seat belt is actually 0.6. So that means P is 0.6, remember? And that means someone is using the seat belt and the others are not using it. So automatically Q will be 0.4. 40% are not using the seat belt. Selecting 5 drivers means this will repeat 5 times, so n equal to 5. That's n equal to 5. What is the probability? 3 of them use the seat belt. The number of successes at the end, I want it to be 3, so that is x. I want the probability that x equal to 3. Okay, so that is, now I got everything. I got n, I got p, and I got x. The next question, 1 out of 5 young drivers speed over posted limit, and there's a sample of 20. So where's n, where's p? A sample of 20 means you selected 20, and that means n equal to 20. And if it's 1 out of 5 use or speed over the limit, it means this is the event I'm interested in. This is what I consider to be success, speeding over limit. So in this case, it will be p equal 1 out of 5, and it will be q, the failure or not happening, what I was looking at or asking about is going to be 4 over 5. I didn't talk about x here. The question might ask, what is the probability that, for example, 4 of them speed over limit, and that will be, in this case, x equal to 4. Now the last example, family with 4 children. When you see that, you know that children has to be either boys or girls, and assuming that they are equal probability. So in this case, automatically, without saying anything, you know the probability of having a boy would be 0.5. That's, suppose this is p now, okay, and automatically q will be also 0.5, okay, and this will be the probability of having a girl, and this will repeat many times. How many times? N. So 4 is n, so n equal to 4. So I got p now, okay, and I also got n, and now I have a binomial. Now the question can be, find the probability that, for example, 2 of the children are boys. In this case, x will be equal to 2. If I say find the probability that 2 boys, if I say the question, suppose the question say that, find the probability of having 2 boys. Okay, and that simply means x equal, that means x equal to. So I got n equal to 4, x equal to, and p equal to half.